All right, welcome everyone. We'll go ahead and get started here now. It's 11 o'clock Central Time, so we'll get started right on time. I thank you all for joining, and today we have something a little bit different than our previous couple webinars that we had. Previous ones you can see there were on SMPTE 2110 and ATSC 3.0. If you weren't able to join us for those two, you can head on over to our YouTube page. Just search for Sencore over there, and you can watch those two broadcasts in their entirety over there. So today, those previous ones were on some technologies that are up and coming. Today, we actually have something different for you, which is a new product launch. This is something that's near and dear to my heart. It's kind of my brainchild, and I've been working here for the past probably 10 months on bringing this to you guys today. So I have a couple of panelists with me here today. I'm Jason Dabbert. I primarily am an account representative here at Sencore, but I also do some project management role as well, as is the case for this product. I have Aaron Doughton with me as well. He's another one of our product managers here at Sencore, and Seth Vermalm, one of our senior product managers at Sencore here. We have the Q&A open on the meeting here, so if you have any questions as we go along here, be sure to type your questions in there, and then at the individual breaks, we'll take a few minutes and answer some of those questions. Anything we don't get to, there'll be more time at the end to answer those as well. So a little bit of an agenda here. We're just going to go through a bit of a brief history lesson, kind of where we've come from, how we've done signal collection in the past, what was applicable then, how it's applicable now, and kind of where we're going. Why would we change from those methods? So we're going to discuss a little bit about that. Why is a good time to change now, and what are the reasons for those changes? Then we'll jump into our new product here, which is the SCP-2100. Talk about that, its capabilities, as well as some internet delivery mechanisms that it allows you to do. And then we'll finish off with a few other Sencore products that enable internet delivery and would be good complements to the SCP-2100. So moving on to our brief history lesson here. So temporary signal collection, how we've done it in the past, and we still do a lot of this today, are one of probably three primary different ways here. Obviously, the first one there, satellite uplink truck. It's very applicable today as well, depending on what event you're going to or what event you're broadcasting. But the biggest problem there is it's very expensive, both to obtain the truck as well as to run the truck and the crew of people to deploy that to different locations and do the different transmissions with it. So like I said, there's still plenty of applications for that today. For example, if you don't have an internet connection, or maybe the internet connection is congested, things like that, that it's very much a good method to do your signal collection still. Otherwise, we have news vans. You've seen those, I'm sure, in a number of different places, doing live broadcasts, doing a microwave link straight back to the studio. And again, those are still perfectly applicable, but you've seen more and more of those type of applications being eliminated and moving towards more of like a bonded LTE solution or something that we're going to talk about today with the SCP. So again, the big things there is that it's quite a heavy asset as far as monetary, as far as from a monetary standpoint, as well as the complexity of the crew that you need to have with it and all of the equipment that goes along with that. So. And then the last one is a fly pack there. So if you have an event that's going to run for a short amount of time, maybe you can package up all the equipment you need for that event, pre-wire it, pre-configure it, and then strap that down to a pallet and freight it off to wherever that needs to be able to collect the signals from that event. So there again, it's a lot of equipment. I just showed a brief example there, but it could be an entire rack of equipment, a full-size rack of equipment, or it could be as simple as just a dozen RU or so that we're showing there. And the other thing we need with that is we're still going to need some sort of probably leased fiber connection in order to get that back to our head end. So that was more of a temporary signal collection. So for a short event or maybe a live news feed, something like that. But if we have something that's more permanent, say we're going to have this installed for a couple of years or something, then we typically see something like this. We have a rack or more of equipment maybe stashed away in the basement or a closet of a local news station or something like that. And we're receiving an ASI or an IP feed from that news station. We're doing our conditioning on that feed, whether that's remultiplexing it, encoding it, transcoding it, remultiplexing it, et cetera, and then dumping that off onto a dedicated fiber and heading that back to our head end or whatever workflow we're running that into. So just showed an example here. Obviously, this can be as complex or as simple as you want, but traditionally, you're going to have at least a decoder, an encoder, likely a multiplexer on site as well as some monitoring equipment, some remote access equipment, all of those types of things, and they quickly add up the complexity and the amount of equipment that's required in order to just be able to obtain a simple multiplex from a TV station. So I showed a little bit of a signal path on the bottom there about how this is traditionally done, whether or not it's at a TV station or somewhere else locally to that market. But this is an example of a AVSB reception. So we'd have our antenna on the roof, run that into a receiver decoder to decode that down to baseband, run it into an encoder, likely to switch that to H.264, multiplex that together with maybe some other local signals, and then drop that onto some sort of leased fiber and head that back to our head end. From there, we can recondition it again, remultiplex it with the rest of our signals, and then finally rebroadcast that out to our end customers. So like I said, just a brief history lesson. I wanted to go through kind of the ways that we've done that in the past. Like I said, a lot of those are still applicable today, but I think there's a better solution for a lot of different scenarios that is both more economical and easier to deploy. So that's where the SCP comes in, and we'll talk about that here in a moment. So why should we change? The big one is cost, right? All those solutions, if it's a satellite truck, a news truck, a full rack of equipment, et cetera, all that stuff costs a lot of money. That equipment is not cheap, and at the end of the day, what management's looking at and what the accountants are looking at and everyone else, they see how much it costs to do that. And if we can reduce that cost, we can likely go and get more unique content where previously it wouldn't have made sense to roll $1 million satellite truck to go get, say, a Little League football game or something like that, right? And bring that back to the head end. So this is really the advantage of getting to a lower cost solution that allows you to still bring back content reliably. The second one there is the complexity, and we touched on this briefly earlier, but the complexity of a lot of those systems in just adding on all the different individual pieces of equipment, not to mention the cabling between them, the power requirements, cooling requirements, et cetera, it adds up quickly. Then you need a specialized technician on site that knows how to run all those different pieces of equipment, as well as configure them, get them wired up, those types of things. So if we can reduce the cost, reduce the complexity, it's just that much easier to be able to quickly deploy and get unique content back for your subscribers. So I did touch on this here in the last slide, but the big thing is as your consumers and providers are moving more and more towards OTT delivery, your subscribers are really continually asking for more and more unique content. And I think we've seen that here. We've all seen that here with the Tiger King, obviously. That's really some strange content, and it's become a huge hit on Netflix, right? So as we move more and more that direction, I think a lot of that unique content will be showing up more and more. And I think it just really diversifies the content that's available not only for VOD, but for live applications as well. So I put a couple different examples on here. Obviously, a Little League game, maybe your 10-year-old's baseball game or something like that. Or the bottom one's a really niche application. We got some RC car racing going on. So these are like just touching on the tip of the iceberg, right? But there's tons of different applications that even I can't even think of that I'm really interested to see kind of how people utilize this in order to get that content back. And the more of that unique content we get back, I just put an example on there, the more we stay ahead of the competition and we are able to retain customers and not only retain them, but gain new customers as well, right? So we've seen that, I think, with some of the streaming providers that people will just go get the subscription to watch one of their unique content series on there, binge watch the entire thing, and then maybe cancel it. Obviously, that's not what you want, but the idea is that you get the customer to sign up to begin with, and maybe they'll find other unique things on your platform and keep them a subscriber, right? So why else? A couple other things here on why we should change. There's been a lot of advancements here in technology, say in the last 5 years or so, 5 to 10 years. Really, the big ones are the internet streaming protocols. So I know back in the day we tried this, doing some SMPTE 2022-1, just basic MPEG over IP, error recovery, forward error correction, and trying to put content over the internet using that FEC. Well, the problem is with that FEC, it was really designed around recovering a couple of different sporadic packets that were lost. And that's what you would typically see on, say, an internal private network that maybe has some congestion. Well, once you start sending those signals over the open internet, what you see is large chunks of contiguous packets that get dropped or maybe delayed in the transmission to its final destination. And the traditional 2022-1 FEC is not great at recovering those large chunks of packet loss. So that's where these other protocols came along, like ZXI, SRT, RIST. There's some other ones out there, like LTN and VideoFlow. There was a big group of them that all came at once with similar competing technologies, but ultimately all trying to solve the same problem. So now we've kind of settled down to probably 3 primary ones that people use the most. I'm sure you're all familiar with the ZXI. SRT is the open source one that Haivision came out with, and then RIST is now the SMPTE standardized one that the VSF created. So these are the ones we see the most. In general, we see very reliable delivery with any one of those over the open internet, and that's really what's enabled us to move to this next generation product. The second thing is the faster public data lines. Obviously, the internet keeps adding capacity on a daily basis. There's plenty of news stories where they're adding transatlantic capacity. There's constant upgrades in more fiber going in the ground, bigger and badder network equipment, those types of things that as those pipes get bigger, we're able to transport not only our 5 meg streams now, but we can send back a whole 20 megs, 50 megs, you name it, right? 10 gig connections are getting cheaper and cheaper, which seems crazy that we can do have a 10 gig connection for what it would have cost us previously to have maybe a T1 connection, right? So those 2 things are the primary things that are really driving this product's evolution. And then the last one there is lower cost and more powerful hardware. So we'll touch on this in the next slide, but the ASICs and dedicated hardware that's out there, those chips are getting faster and less expensive and more powerful every single day. So as the industry moves towards software, we see a need that there's still going to be a hardware need, and that's where the SCP is going to come in. So moving on to that, what about the software? You see all the manufacturers really pushing the software-only agenda. Let's just install it on COTS hardware. We can quickly change that COTS hardware to be something else just by installing new software on it. And that's great. It really allows us to be flexible, run different VMs on there, and really utilize just normal computer hardware for lots of different things. But even Sencore is moving that direction with a lot of our products, but we also realize that there's still a need for physical inputs, especially on the front end of your signal path. So at the front end of your signal path, you typically have lots of different physical types of inputs, whether that's a BNC input or an F connector or an HDMI or an SDI, right? There's all those types of inputs in the front end of your signal path. Once you get it ingested into the signal path, then we can keep it IP all the way through until we finally deliver to a customer, whether that's finally modulating it to QAM on the end, or delivering it IP straight to the customer, or modulating it maybe to satellite and doing a direct-to-home satellite signal. So there's definitely still a need for physical hardware inputs, and I think there will continue to be that need for the very distant future here. So let's stop there for a second. Went over a few different things there as far as history and kind of why it makes sense to change right now. Let's see if there's any questions, and then we'll continue to move on.
Yeah, Jason, we had an interesting one specifically around backhauling AVSB signals. There's just some challenges and stuff involved with that. And one of the questions was AVSB signals are statistically multiplexed, and what's the best course of action when backhauling a single service?
Yeah, that's actually a pretty interesting question, and an interesting one to try to find a solution for. The biggest problem you run into there, if you're just trying to pick off a single service and trying to backhaul that. So say, for example, in ATSC AVSB signal, we have maybe 3 to 5 to 7 services in that multiplex, which are all statistically multiplexed together. And maybe we only care about that primary HD service, and that's the only one we want to bring back. Well, we can't just take that single service out of there and send that back, because that service, since it has been statistically multiplexed, the video bitrate could fluctuate quite a lot depending on how they have their multiplexer set up. So if we just pull out that individual service and send that on restamped PCRs, now we have a wildly varying transport rate as well on the output. And the second thing that comes along with that is there's no null packets in there now. So their downstream receiving equipment, most of it is set up to receive a constant bitrate transport stream with some percentage of nulls in it. So most of that downstream equipment, in order, it's set up to receive that constant bitrate stream, so it will just, it has a buffer defined on the front end so they can ingest it and account for any latency or jitter in the physical layer and put that into the buffer and clock it out into a nice, a smooth transport stream inside the device in order to do their processing on it. Well, now if we don't have any null packets and our bit rate is fluctuating quite drastically based on the multiplex rate, the downstream equipment, the buffer, is going to be all over the place. Whether that's overrunning the buffer or underrunning the buffer, it's going to cause lots of problems. So really the nicest and most elegant way to get around this is to do some transcoding at the edge when you do the ingest. If you don't do the transcoding, you could maybe do a constant constant bit rate on your output, but then you would need to be able to define what that upper and lower limits are on the multiplex, put in X amount of null packets, and then just have a constant bit rate on the output. But now that'll work just fine until the provider changes something. Then you have to go recharacterize that whole link again, go through that whole process again. So if we do transcoding on the edge, we can take that single service, bring it in, do the transcode, and then just output a single program constant bitrate transport stream at probably a lower bitrate as well, because we'd likely transcode it from MPEG-2 to H.264, run it across the internet. Now I don't need as much internet bandwidth either. So I see that as probably the most elegant solution to that problem.
All right, cool. Thanks for the detailed answer there. I think we can move on to the next section.
All right, sounds good. So moving on here, we'll talk specifically about the SCP-2100 and kind of how it plays into the things that we just talked about, as well as that transcoding question that actually played quite well into what we're going to talk about here. So the SCP-2100. So what is this thing? It's a low-cost, all-in-one signal collection platform is what I'm calling it. So you'll see here, it's a small little device, about 1/3 of an RU wide, 1 RU tall. It's really meant to just be a throwdown box that can do encoding, transcoding, gateway functionality, all those types of things. Bring it in, do your processing on it, and then send it across the internet into both either your cloud workflow or back to your head end to do your head end type workflow on it. So the idea being here is that you could take this box, ship it out to a location, and whoever's on site can plug in whatever type of input they're being handed. So maybe they have a BNC there and they don't know what's on it. Could be SDI, could be ASI, who knows. You can see we have a BNC in the back there that's SDI and ASI. It will auto detect what's on that signal. And based on that, you can either do your encoding if it's SDI, or do some transcoding in the case of ASI, or maybe you just want to pick off a couple of the services, or maybe change the PIDs or service numbers and send the entire thing out. You can do all of that on that ASI signal then. So it's designed to be very easy, that anyone on site can plug in what fits, so to say, and the device will figure that out, and then you can do the applicable processing that you want to on there. The final thing I wanted to point out here is that it has a front panel, as you can see, for your status and monitoring, as well as your network config, but you can do all of your configuration of the unit remotely as well. So we can use the web GUI that's built in, like you're used to seeing on all Sencore products. We have a full XML-based API, SNMP control, along with traps. And then we have Zixi ZenMaster integration there as well. So in that case, you can ship it out to a location, plug it into the internet. Now it pops up in your Zixi ZenMaster, and you can do all your configuration remotely right there. So makes it very quick and easy. So as far as inputs are concerned, we have 2 RJ45 1 gigabit connections on the back there. We support unicast and multicast, both ingress and egress. So you can do that either way there. ASI we talked about, SD and HD SDI, HDMI with HDCP compliance on there, so we can come straight out of a camera, plug it in there. The other thing I added on this product is that positive screw retention. So you can use an HDMI cable that has the screw-in connector on there, so we don't accidentally have that HDMI cable fall out of there in the middle of a broadcast. And then the final one there is the RF in, as we called it. And the reason we left it that vague is from the get-go here, we're going to launch with 8VSB and QAM as our inputs. And the idea is here is that we'll add additional RF front ends in the future. So we can add potentially a DVB-T, DVB-S, S2, all those types of things. That RF board internally is a factory modular piece of equipment. So we can easily change that in the future to add additional capabilities to this unit. And then the last thing I wanted to note is that both of those Ethernet ports, you can use them both for management and both for video, either simultaneously or individually. So makes it quite flexible. So the processing. So I just wanted to kind of illustrate here what type of processing is inside of this unit. So we touched on a little bit of the encoding. So we'll do H.264 encoding up to 1080p 60, and this is all ASIC-based encoding. So you should get really nice quality encoding at very little power. So we do transcoding, MPEG-2 and H.264, again to H.264. So all of the processing has H.264 on the output, and then MPEG-2 or H.264 on the input there again. So we can transcode both stuff from the 8VSB terrestrial broadcast or any H.264 videos that you're receiving there. We also do PID and service filtering. So we can remap services, we can cherry pick off individual services, really anything there to better condition the signal to fit into whatever your workflow looks like. So say you have a particular service number scheme or service names or PID scheme based on service numbers, you can edit all of that right here and make any input signal look how you want it to on the output. And then obviously we can do pass-through as well. So we don't have to do any of this processing. You can come in any of the compressed inputs and just send them straight to an output, whether that's traditional MPEG over IP, a unicast or a multicast, or maybe we'll send that over to one of the internet delivery protocols, whether that's ZigSee, SRT, or RIST. So I just kind of illustrated that here, how the different inputs map to the different processing sections, and then how those map to the individual outputs, and then how those outputs end up either back at your head end for into your traditional workflow or into your cloud-based workflow as you move towards a software type of a workflow. So onto the outputs, we touched on this a second ago, but traditional MPEG over IP, unicast, multicast, UDP, RTP. We also support the 2022-1 FEC, like I talked about earlier. So if you're running this internal to your facility, maybe you have a AVSB antenna on your roof, and this is going to ingest that signal for you. You can still run traditional FEC inside of your facility with this box. And then all of the internet delivery protocols that we've touched on a number of times here, this box is ZigSee ZenMaster certified. And the last thing I wanted to note there is that the fan inside this unit is software controlled, and the steady state of that fan is off if it's not needed. So I really wanted to make sure that this unit is quiet and can be installed inside of an office setting if need be, or any other place where noise is of a concern. Typically all your broadcast equipment has fans screaming away, and you can't really even hear yourself think. So they're really not suitable for typical office type applications or where sound is a concern. So I wanted to be conscious of that with this product and try to keep it as quiet as possible. So onto a few different application examples. I know we talked about the 8VSB receive application here kind of as we've been going, but I see lots of other applications where this product will be very useful. And I think I've only touched on the tip of where they're going to be used, or where this is going to be used. And I'm really curious to see what type of other unique applications people come up with for these. So the first one, 8VSB there, that's pretty straightforward. We stick an antenna onto the back of the SCP-2100, do our encoding or transcoding, and send that back over the internet to our head end. Or the next one there, which is maybe a sports broadcast. And this probably isn't what you would typically think of as a sports broadcast, as say an NFL game or anything huge like that, where it probably makes sense to do some production on site, bring out the semi-trailer, et cetera. But this is more along the lines of maybe the Little League game or a soccer match or maybe a table tennis match or something like that, right? Where maybe you have one camera that's focused on the table or the field or those types of things. You would do all your collection with, or your videoing with the camera, run HDMI or SDI into the SCP, do any encoding or transcoding that you need, and then run that over the internet back to your head end again. The third one there is, it's a little bit hard to tell what that is, but I think I can see maybe two different applications for that picture. One, maybe that's a public address. So obviously with all this Corona business going on, there's plenty of news addresses and public addresses. So we could just send a single camera there and run that into a SCP in your backpack, plug that into the internet, and now you got the signal coming back to you. The second application I can think there is maybe a concert or a music event. So whether that's a local musician playing in the park and you want to broadcast that back, maybe that's for some B-roll, or maybe it's just actual live content that you want to put out on your cable plant or your direct-to-home satellite feed or whatever. Maybe it's an IPTV network. Who knows? But this would be a very inexpensive way to go capture unique content and get that back to your head end very quickly and easily. And then the last one there is an industry that we've really been seeing growing here in the last couple of years especially, and that's esports. And I guess that's kind of played into some of this pandemic stuff as well, where we saw the virtual NASCAR race and the NBA doing some virtual events. But outside of those, and we think of traditional esports, we're thinking like the Overwatch League and a lot of those normal computer games that you're used to playing. And now we can take the HDMI out of our computer, run that into an SCP-2100, and now backhaul that over the internet back to our head end, and maybe do some production at the head end and rebroadcast that. As we've seen that grow in popularity, you see people like ESPN and ABC and those types of people even picking up these feeds and running them on primetime television. So, like I said, these are just a few of the ideas that I had on where this type of product would be very applicable and would really make getting these signals back very easy and inexpensive for you. So the big thing here, that the goal with this entire product is that it's very quick to deploy, very inexpensive, and very easy to move around. So like I mentioned earlier, you ship it to the location, have whoever's on site connect anything that fits, and hook the other Ethernet connection up to the internet. Configure it remotely, and you're up and running. So I think you could probably get this all up and running in maybe 5 minutes. So compare that to most other ways of doing signal collection, and you're typically like hours to days in a lot of those cases. So very quick and easy. So as far as ordering information, I wanted to put these on here. These are the initial part numbers. So we're going to offer it in basically 2 primary different flavors, one with the encoding and transcoding in it, and one without. And then we'll have the 8BSB option be an option as well. And as we add the different RF front ends, those will be options too. So you'll see there the 2111, that one will have basically everything in it from the get-go. So 8BSB, ASI, IP, SDI, HDMI, encode, transcode, the whole 9 yards. So, and then down from there, we just pick off features and the price goes down accordingly as well. So contact your account manager if you don't know who they are. You saw our contact information for the 3 of us here on this webinar. You can contact any of us. We'll get you to the right place as well. Or send us a message through our website. We'll get you quotes, get demos sent out. I have a whole bunch of units that just went into manufacturing today for demo units. So we should be seeing those in the next couple of weeks and can start getting those out to you guys to start playing with them. So as far as recap on what the SCP-2100 is, it's really a nice all-in-one device that is very easy to move, quickly to deploy, and affordable are the big things. So really, we don't need receiver decoder anymore. We don't need the encoder, transcoder, multiplexer, the internet gateway, any of those things. It's all done in this single little device. You'll see when you get some quotes on this device that it's extremely affordable, very inexpensive compared to any one of those other devices up in that upper list there. Portability. So I mentioned that earlier. It's just 1/3 of a rack unit wide and 1 RU high. And then the last one is full featured. So if you're familiar with Sencore, you're also familiar with the depth of the feature set that you see on a Sencore product. So this product has all of those features as well. We have syslog reporting, SNMP traps, tons of status information, both on the inputs, the encoding, the processing on the unit health, all those types of things. Lots and lots of statistics inside of the unit there. Really feature-rich, error logs, alarming, those types of basic features, but a lot of those things you wouldn't see on a less expensive product. So very full-featured. I think it's going to be a great product once we get it out there, and I'm really excited to see how people use it. All right, I think we'll take a break there and see if there's any questions.
Yeah, Jason, we got a couple questions that have come in for you. So first one here, can the SCP be rack mounted? For example, if I want to backhaul multiple signals with more than one SCP, can they be put in a rack?
Yeah, absolutely. We do have a 1RU tray that will sell alongside this, just an inexpensive option for this that allows you to put 3 SCPs into a single rack unit. They mount to the tray, and then the tray can mount up to a typical 19-inch rack.
Great.
I had another question. You were talking about doing remote management and stuff like that via ZenMaster, but would there be an ability to actually do remote management, say if you're using any of the other protocols and still be able to access the web interface or anything like that?
Yeah, so at any time, you'll be able to, since this unit will be on the internet, at any time you'll be able to pull up the unit's web interface just by hitting the public IP address or whatever IP is assigned to it at the remote location. So you can pull up the web interface that way, or you can use the API remotely. I'm looking at some other details on maybe getting some SRT hub integration into this unit. I know there's a lot of talk on that. I haven't done much more research to see what's out there and what capabilities are there, but I think in theory that's possible as well. But you don't have to go through any one of those. You could go directly to the unit in any of these cases.
All right, excellent.
All right, some more questions here. Can you expand on the details of the encoding capabilities? Does it support 422, 8-bit, 10-bit? You know, what's the video quality like and the latency?
Sure. Yeah, so this is primarily, the encoding that's in this product is primarily geared towards distribution. So 420, 8-bit for the most part, H.264. The quality I think you'll be quite impressed with. Since it's ASIC-based, that typically leans towards a better video quality in a lot of the experience that I've seen. And as far as bit rates, I believe it goes up to 50 meg video if you want to transport that over the internet. So you should be able to really get some nice quality video out of this product. Did I miss any piece of that?
No, I think you've got it. Do you,
Okay.
you know, as a little follow-up to that, do you have kind of recommended bandwidth it requires for typical internet transport?
Sure. If you're doing a HD H.264 video, I would say you could get some real nice quality, maybe around 8 to 10 megs. So not much at all. Even the some of the lowest internet connections, you should be able to get some really nice quality video back.
Okay, we had some questions about RF front ends and different types of RF front ends. You've talked about 8VSB quite a bit. Are there any plans for doing like DVB-T or DVB-C, even satellite or anything like that? And just kind of what the plans are there?
Yeah, absolutely. So that RF front end on the device there is a module, is modular inside of the unit. So we designed this product to have future RF front ends on it. To be modular like that at the factory. So we were definitely anticipating adding additional RF front ends there. Some of the ones that I've gotten pushed for already are DVB-T and DVB-S2. So obviously the satellite one will likely come with S, S2, S2X, all the nice flavors there. And then DVB-T will obviously come with DVB-T2, et cetera. So I am definitely looking forward to adding those additional RF front ends. This first launch will just be 8VSB, but as you guys bring me opportunities and have applications for these different front ends, I want to hear about them, and then I can get the RF front ends into development and get those out to you right away. So be sure to, if it's not me, talk to your Sencore account manager, and they can relay all that information to me, and we can see about getting those different RF front ends accelerated and engineered for you.
And then to expand on you know, the multiple inputs and stuff like that you had talked about, there's been some questions about input redundancy and stuff like that. Like, for example, could you have an HDMI input and an RF input and fail over between the two, or you know, what kind of combinations and stuff like that are possible?
Yeah, absolutely. So like most Sencore products, we have pretty extensive input redundancy features in this product. So you can define both a primary and a backup input, define what parameters are used to failover on, whether that's, in the case of a transport stream, whether that's a TS sync loss, or whether that's a processing error, which would be like in the encoding example, or any number of other different parameters that you can choose to do your failover on. Then when you fail over, you can also define if and when you fail back. So in most applications, people don't want to have a unit that's failing back automatically. They want to go figure out what happened to the primary input, make sure that's rectified, and then do a manual fail back to the primary. So we allow you to do the manual, we allow you to do automated, and we allow you to set a timeout for any of those failovers as well. So maybe if we have a 1-second transport stream interruption, we don't want to automatically flip over to our backup. We'd rather just take that 1-second interruption and stay on our primary. So we allow you to define all of those timeouts as well. And as far as which inputs you can switch over between, you can switch between any of them. So if you're receiving a transport stream and you're just sending that out, and you want to fail over to, say, an SDI or something like that, that has to be encoded, we allow you to do that as well. So you can pick and choose between any of the inputs and do any redundancy that you want there. It's very flexible.
Okay, we've got a question about audio support on the encoder side. How many channels does it support and what codecs?
Yeah, so that's a good question. On the audio side, we have support for 2. I always like to talk about these in PIDs because people start talking about channels and pairs and those types of things, and people interchange all the terms. But from a transport standpoint, we're talking about 2 PIDs of audio, 2 stereo PIDs. So I guess it would be 2 stereo pairs that are supported there, and we pass through any of the primary or main audios, whether that's AAC, AC3 or MPEG audio, pass through any of those, and we will encode or transcode to AAC.
Okay, another couple questions about decoding, and I think there's maybe a little confusion here. Is the SCP able to act like a decoder? And if not, do you have any recommendations for decoders to use on the receiving end?
Yeah, so the SCP is meant to only be on the front end. So an encoder or transcoder receive all your signals on the front end and then send them off back to the head end or something like that. That's going to receive those signals and do the decoding. So as far as a decoder is concerned, we're going to talk about some of the Sencore products here coming up in the next few slides as far as decoders are concerned and or gateway products are concerned that could receive these internet transport protocols and either turn them back into a traditional transport stream or decode them directly. So I guess I'll save part of that question for these next slides, and then if there's additional details I can add after that.
And one more question here. Can you talk about the latency of the SCP-2100 as it relates to encoding and transport?
Yeah, so I don't have the official details in front of me yet. I'm still working on doing the final testing on the latency there and doing some tweaking on it. But the encode latency will, in most cases, probably be similar to what the latency is across the internet. So in most cases across the internet, you're going to get 30 to 60 milliseconds of latency. And on the encode side, you're probably going to be in a similar ballpark there, probably a couple frames of latency. And I'll have more official numbers on that as I get closer to the release date here.
All right, that's probably enough for now. Why don't we move on and we'll catch some more questions at the end.
Sure, that sounds good. All right, so moving on to a few other solutions that Sencore has for internet delivery that would be great complements to this type of product. So just transporting over the internet, I put a little paragraph in here, but it is the year 2020. It's been an interesting year to start off with, but we're already moving lots of data across the internet, and the last couple of months especially, we've been doing more and more of this. And moving that data across the internet is not a new topic. We've been doing it for the last few years already. We've proven it to be reliable and an inexpensive way of delivering content. So what's new is a cost-effective way in order to do video and deploy and collect signals across the internet. And that's what the SCP really allows you to do. And with protocols like SRT and ZXI and RIST, even HLS, they've really enabled the transmission, reliable transmission of video signals across the internet. So the couple of the products I'm going to talk about here on the right-hand side, I just wanted to highlight, but we talked about the SCP, obviously. The next one we're going to talk about is our DMG 7000. Then we'll move on to the MRD 7000 and finally the DMG 4000. So the DMG 7000, this is a perfect complement to the SCP 2100. So this is our Internet Transport Gateway. This is a software-based product that you can install on any hardware. It can be installed on a VM, can be installed on a cloud instance, as we've highlighted there. But really the idea here is that you would deploy your SCP out to the live event, capture it, do any processing, send it across the internet, and then maybe you'd have one of these DMG 7000s at your head end receiving the signals from all of your SCP 2100s out at the edge. Then the DMG 7000 is receiving all those different protocols, turning them back into MPEG over IP, and dumping them into your typical production workflow. The other thing, DMG, we have 3 different sizes of this product, and really the only difference is the capacity or the number of signals that each one of them can process. So we have a small one similar to the SCP-2100 that will just do a small number of IP feeds. So that could be deployed at the edge where you have only IP feeds. Now, if you need any of the other hardware or physical inputs, whether that's RF or ASI or SDI, those types of things, then you could deploy an SCP-2100 out to the edge. So those 3 different styles, you can deploy those remotely or at your head end. But I think for the sake of this conversation, the SCP out at the edge, DMG 7000 at your head end, or maybe at the ingest to your cloud instance would be a great complement to one another. The MRD 7000, so I wanted to talk about this one a little bit since we had that question earlier, but this is our software-based decoder platform. Really, we designed this decoder platform kind of out of necessity to handle high bit rate 4K HEVC contribution type feeds. So 422 10-bit, 160 meg video rates, those types of things. And since then, we've had additional applications in distribution where we need to do have a flexible platform and do multiple channels of decoding in a single platform. So this MRD 7000 is really the Swiss Army knife of the Sencore decoder lineup here. So really, you can throw basically any type of input at this thing, physically or protocol-based, any codec, really, we can decode all of that, and then really all the different types of outputs, whether that's your traditional baseband SDI, 3G SDI, 12G SDI, or if you have a new IP-based baseband workflow using SMPTE 2110, we can natively output that as well. And then we have BIS-CA decryption that we just added in there, and then the legacy BIS-1 and BIS-2 encryption there. So if you're looking for a decoder to decode these feeds directly, MRD 7000 would be a great choice, and you can actually receive multiple feeds from different SCP-2100s and decode them all in the same unit here. And then lastly is the DMG 4000. Really, this is a Swiss Army knife head end in a box type of a product. So I didn't put the back ends of these 2 products on here, but they're a completely card-based modular chassis that has ASIC-based encode modules. We have ASI multiple 10 gig modules, SDI, we have your SRT and 6E inputs and outputs. Basically, you name it, this product has got it. And it has modulator modules even as well. So really, this product is designed to be a very, very dense gateway product. And it was originally designed around an IPTV firewall type of an application. So the idea there is that you would run all your video feeds into this product and then hand them off as IP as well to a different provider. And in this product, since a lot of it is IP in and IP out, what we actually do is come in, take everything back to transport stream internally, and then encapsulate it into IP on the output. So there's no way of any nefarious IP packets or content getting through this product. So it's a great firewall for that application. And you can see there we can support up to 2,500 streams, and we have 140 gigabits of throughput in this platform. So very, very powerful platform. And I've even done some contribution uncompressed applications with this product as well, running 96 gigabits per second over like a 50-kilometer link. So pretty unique product, very powerful, and another great complement to the rest of the internet delivery protocol or delivery products in the Sencore lineup. I think that's all I had. We'll stop here for the last few questions.
Yeah, one of them was, would it make sense to actually have a wireless front end for IP backhauling? This was actually, I think, specifically around the SCP-2100, given the fact that you can throw it down pretty much anywhere at a remote site, and this might be a different kind of input.
Yeah, so I don't know if we're talking about inputs there or actually outputs, but I did have an idea to throw some maybe USB 3.0 ports on this. And you could put maybe an LTE or a 5G modem on here in order to backhaul it that way over a cellular connection maybe. Otherwise, I'm not sure what other type of wireless inputs you would have, but I have had that idea, and it is on my list of things to explore.
Another question back to the SCP is, can you talk about ancillary data support, from the SDI input?
Yeah, absolutely. So from the get-go here, we're obviously going to have closed caption support. I have SCTE 104, obviously translating that to 35. I have that support slated for the next release here. And AFD, I don't have that on the roadmap yet, but it is on my radar. And then I'm not sure what other SDI stuff we would want, but maybe some WTSI or VTSI timing or things like that. But
all right, another question about future capabilities. Again, kind of just expanding on the RF front end stuff, but this one's a little bit more unique. So is there any plans or feature capability with ATSC 3.0 being a front end or an input to this box?
Yeah, so it's certainly something that we're considering. The biggest problem, again, with ATSC 3.0 is the lack of a transport stream. So in this particular product, obviously it's geared around transport stream still. But if we put an ATSC 3.0 front end on there, I see no reason why we couldn't just hand off the base IP packets into our traditional encoding and transcoding platform in order to transcode those back to H.264. The only thing I see as maybe a stumbling block is doing HEVC, since the ATSC 3.0 will likely be HEVC. So that would be a thing I would need to explore yet.
All right, and one final question here. Do you have any plans for descrambling or BCI in the future?
Absolutely. So I think those DVB-CI and DVB-S or S2, those in my mind are synonymous with one another, and you can't really have one without the other. So when I add that satellite input, there will likely be a DVB-CI slot on the back as well. So if I go back here a second, my idea is obviously the satellite would be right where the RF in, and then where those vents are right to the left of it, there's plenty of room there to fit in a DVB-CI slot in order to allow the descrambling. So great question.
I think that's the end of our questions. So.
All right. Well, I thank everyone for joining again. As a reminder, this whole presentation was recorded, and you'll get a link to the recording after this, and we will also be posting this on our YouTube page. There's one more webinar coming up next week, so watch out for the invite for that, and have a good rest of your day. Thank you.